Okay, so there's going to be more steps added to this one because it requires more steps. So make sure you're aware of that. This is more like what's on the worksheet because we have y by itself, but it's equal to an expression 2x minus 1. Again, this is substitution method. We're going to use it because one of the variables, in this case y, is by itself. So that's what we're going to do. So what do you guys think this y on the bottom is going to be replaced by? I haven't heard the right answer yet. Yes? Nope.
1.
Nope.
2x minus 1.
There you go, 2x minus 1. What y is equal to the top? Y is equal to 2x minus 1, so it will be replaced with 2x minus 1. However, let's just follow the steps. Okay, guys, so we're going to be circling the top equation because it's the one where the variable is isolated. Again, you don't have to write the steps out twice, but that's the step we went over from previous, step 1. Any questions on that? Okay, next, we are going to locate the variable in the other equation, the bottom equation. So you guys see that's where the y is? Step 3, let's read this together. Replace the variable here with its equivalent expression. So y is going to be replaced with 2x minus 1.
So the 2x's would cancel out?
They will, because it's minus 2x plus
So that would be
2x.
equal to 1, negative 1 equals 4.
We'll talk about that. We've talked about something. Does anybody know what happens when you get that? Negative 1 equals 4?
Don't you plug it in back? No.
Okay, I'll talk about it. But he's right. These are going to cancel because one is negative 2x, the other is positive 2x. Okay, see what step 4 is. Solve for the first variable. So here's what happens. The negative 2x and the positive 2x cancel. We get negative 1 equals 4. I told you now, whenever you get two different numbers that equal each other, that's a problem. When does negative 1 equal 4? Never. Okay? Because it never equals, the answer to this question is no solution. Okay? In other words, there is no number for x or y that will make both equations true. And I'm going to show you graphically what that is. Good point. What's up with these two lines? Say that again.
They're parallel.
The parallel. They'll never cross. So when you have two equations that are parallel, they're not going to have a solution. There will be no point of intersection. Another great way of visualizing this one. Just like train tracks that never meet. Go ahead and write the rest of these steps down because we're going to apply them for one more example, which I will do next.
Technically, train tracks do cross.
Yeah. Okay. So step 5, if you do figure out one variable, plug it into the first variable's value back into the equation and solve for the other variable. And like I said, we will do that. I think I'm going to do number 1 on the worksheet once you guys get these steps copied down. This question I wanted to do because I wanted you to see what no solution looks like when two lines are parallel. Okay, so normally once you figure out x, you would plug x, that value for x, back into one of the equations and solve for y, one where y is by itself. So let's go ahead and take a look at an example that looks like that.